Let us work few problems related with the shift registers. A 4-bit right shift register, initial content is 0101. After 2 clock pulses, what is the content of the register? It is the question. So the initial content we are looking at 0101. After 2 clock pulses, the question is after 2 clock pulses, what is the content the register? What is the content of the register after 2 clock pulses? We need to work like this. Nothing is mentioned so that you can consider default. It is a flip-flop corresponding to the MSB and so on. It is a flip-flop corresponding to LSB. Hence Q3, Q2, Q1, Q0 are the respective flip-flop outputs. Q3 is the MSB flip-flop output, Q0 is the LSB flip-flop output. So we are looking here. Initial content in the register is 0101 and serial input. We are reading by using exclusive OR gate, so that it is a exclusive OR between Q1 and Q0. Before applying any clock signal, what is the serial input? If you look, the serial input 0 exclusive OR 1 is 1. So that as and when we are applying the clock signal, the content in the register is 1, 0, 1, 0. So that these bits are shifting to the right and the serial input data is coming to the MSB flip-flop. Now before second clock pulse, what is the serial input? If you look, Q1 exclusive OR with Q0, 1 exclusive OR with 0 is 1. So that after second clock pulse, we'll be having the content in the register as 1101. Hence, answer to this question 1101. It is the content of the register after 2 clock pulses. It was a question couple of times in the GATE exam in the IES papers. Of course, not a very difficult question, very straightforward, simple question only. Let us try for one more question. Here we are looking at a question. A 4-bit right shift. It is a right shift. Okay. A 4-bit right shift register is shifting the data to the right for every clock pulse. The serial input D is derived by using exclusive OR gates as shown in the figure. So it is a 4-bit shift register, serial input D, which is derived by using these exclusive OR gates, so that you can able to read the D input is nothing but exclusive OR between Q3, Q2 and Q0. So 1 bit we are looking, the initial content in the register is 1000 at Q0, Q1, Q2, Q3. After how many clock pulses this circuit, that is the register, is back to initial state? It is 1 bit. Second bit, after a clock pulse, the content in the register is to be 1010 at Q0, Q1, Q2, Q3. What will be the initial content of the register? It is a second bit. It was a question in the GATE exam 1996. It is a good question. Try to keep attention and try to identify. In the description of the question, there is a small hidden thing. We need to identify that hidden thing well. That is very important to conclude the answer properly. It is a right shift register. Once it is a right shift register, the data will be shifting from MSB to LSB. Based on this problem description, based on this figure, MSB bit is flip-flop 3 output, that is Q3. LSB bit is flip-flop 0 output, that is Q0. So the data will be shifting from flip-flop 3 to flip-flop 0. So while looking to this figure, normally the mistake what we will be doing is, while looking Q0 nearer to the D, what is the serial input D is entering, mostly we will be trying to transfer the serial input D first to flip-flop 0. It is wrong. The serial input D is not transferred to the flip-flop 0 first. The serial input D will be transferred to the flip-flop 3 first. That is the hidden thing. instead of the notation Q0, Q1, Q2, Q3, if at all we are looking the notation as something like this: QA, QB, QC, QD. Then if I am in the problem description, if at all we are not talking which is LSB, which is MSB, default you can consider QA is MSB and so on, QD is LSB. But whenever we are having a description with a decimal subscripts like this, it is not allowed to consider Q0 is MSB. Highest decimal number is MSB. It is a block diagram representation. In this question paper in the 96, it is given intentionally to make the student for proper attention purpose. Instead of this notation, even if at all I am looking something notation like this: Q2, Q1, Q3, Q0, even if at all we are talking like this, default the means the only block diagram representation, Q3 is MSB and so on, Q0 is LSB. While looking to the Q2 nearer to the D, it is not the means the Q2 is MSB. So this thing, if at all we are taking care properly, the question is not difficult. Most of the students will be doing the mistake while considering simply Q0, that the D is transferred to the Q flip-flop 0, while taking the Q0 as MSB, people will do the mistake. It is very clearly mentioned in the right shift register. Once is the right shift register, the data will move always from MSB to LSB. With the left shift register, the data will shift from LSB to MSB. It is standard notation, unless it is not mentioned specifically. So while taking care like this, if you look to the solution of the A bit, for our working purpose, it is better to keep the notation from Q3 to Q0. Serial input D, initial content 1, 0, 0, 0 at Q0, Q1, Q2, Q3. Now, based on the question, we need to go on apply the clock pulses until the register is back to the initial state. So after how many clock pulses it is back to the initial state, that is the answer we need to give for A bit. Before the first clock pulse, if we look to the serial input, it is the exclusive OR between Q3, Q2, Q0. So be clear, as far as the serial input D is concerned, Q1 is not coming into the picture. So mostly we may do the mistake in a hurry while looking to the serial input D, also taking the Q1 into account, we may do the mistake. There is also other mistake, it is possible. Anyway, if you look here, 0, 0, 1, hence odd number of variables are 1, serial input D is 1. Now if you apply the clock signal, we are looking, it is the content we are having, we are looking in the register. Before second clock pulse, we look to the serial input Q3, Q2, Q0, 1, 0, 0. So again it is 1. The second clock pulse, we are looking, it is the content. And before third clock pulse, Q3, Q2, Q0, even number of variables are 1, so that exclusive operation result becomes 0. If you apply third clock pulse, we are looking, it is the content in the register. As we know, as per the question, we are supposed to go on apply the clock pulses until we are back to initial state. It is not back to the initial state, we are going further. Before fourth clock pulse, Q3, Q2, Q0, if you look, it is 1. In the fourth clock pulse, we are looking, it is the content. Before fifth clock pulse, if you look, Q3, Q2, Q0, 0. The fifth clock pulse, we are looking, it is the content. It is not the initial state, so we are going on applying. Before sixth clock pulse, Q3, Q2, Q0, 0. So that we are looking, it is. Before seventh clock pulse, if you look, Q3, Q2, Q0. Q3, Q2, Q0, it is 0. So that after seventh clock pulse, we are looking, the circuit is back to initial state. Hence, answer to this A bit, the answer to the A bit, we are looking as 7. The circuit is back to initial state after seventh clock pulse. It is the correct answer. But wrongly, if you take D is transferred to the Q0 first, then the answer you are not going to look as 7, you will be looking to the wrong answer is 6. A small thing will be having that make you to give the wrong answer. Okay, coming to the B bit. Based on the question description, after a clock signal, the content in the register is to be 1010. After a clock signal, we want to read the content in the register is to be 1010 at Q0, Q1, Q2, Q3. What will be the initial content of the register is the question. So if you look here, after a clock signal, if you want to read Q3 to be 0, then D must be, serial input must be 0. After clock signal, we want to read the Q2 to be 1, then Q3 must be 1, Q1 to be 0, so that Q2 must be 0, Q0 to be 1, so that Q1 must be 1. So we are looking here, Q3 is 1, Q2 is 0, and we want to read D is to be 0, then what will be the Q0 is the question. So if at all we are talking Q0 as 1, then only the serial input D becomes 0. Hence, Q0 must be 1. Hence, the answer, if you look, the answer by mistake people may write as 1011. It's the wrong answer. The answer will be 1101. No doubt, if it is a multiple choice question, A bit may be, option A may be this, option A may be this, it may be some C or D. It is the wrong option. The correct answer will be this. The reason is, everywhere in the problem description, the order is mentioned from Q0 to Q3. Default, the answers what we are looking in the multiple choice, they are also with the same order Q0 to Q3. Hence, the answer will be 1101. So, it is the answer. It is one of the good question, and we will be having generally the questions of descriptive as well as objective of this nature from this shift register topic. Take previous question papers and look to the problems of shift registers. Mostly you will be having a problems of this type, and you will be having some questions related with the shift register application. Sometimes you will be having questions in the match the following. In the list A, you will be having shift register, decoder, something items like this, some devices like this, and in the list 2, you will be looking generally the applications of each one of the devices which is present in the list 1. So in the list 2, generally you will be looking one of the application of the register. So these are the generally scope of the questions in this topic.